Okay, section 13, and certainly we'll cover this as a lecture first, then examples, and then you work on your own. It's really the same old, same old. All right, so I realize this section might be rather difficult, and this is where I really do believe machines come into play over here, but we'll talk through it. And again, I want to remind you little tiny videos over here for those students that need that supplemental support. All right, there's also availability of office hours. After you put a considerable effort in, you need help, please come by and we'll give you help. I really do mean that. And Essex is all about helping students move forward. So, something old, we've done this before. Certainly you've done something like this in Math 100. I'll go to the whiteboard later. We've done this augmented matrix. That wasn't so bad. I kind of like that technique. But again, your mileage may vary. You may say, I like this technique over that technique, but we need to move on. And this is really the domain of linear algebra. But what we're going to start doing is talking about something new. What we're talking about, we're talking about the coefficient matrix. We'll talk about this thing, how it relates to this coefficient matrix. We'll talk about a variable matrix. Notice I'm using an uppercase letter A that's in bold to indicate a matrix, just like this uppercase letter X to indicate a matrix. Now, this matrix has two things in it, X and Y, and they're the variables of this system. We're going to about a constant matrix. And again, I'll relate it back to the original problem when we get to the whiteboard. We talk about a matrix equation, and then we talk about how to solve the matrix equation using matrix algebra. The problem with matrix algebra, though, is getting what's known as an inverse, and that's what's indicated over here. You should be well aware -1 means the inverse of the matrix A. We'll talk about that later. That, generally speaking, is not easy to do. However, we will do reasonable problems where these things are easy to come up with. However, a lot of times I just give you the inverse, but I want to show you how to find an inverse at some point. All right. So what do we do over here? I'll go through this algebra for you. I know it looks terrible. You might say, I can't do that. I can't do that. I can't do that. You got to try. When you start trying, then you can start saying you can't do it. All right. It happens. Like you can try to lift up a car and say, well, gee, I can't do it, but at least try. And then you say, oh yeah, I really can't do it. Well, you try again, maybe eventually you'll get it. Right. So we talk about other systems, get bigger, more nasty. I do like this reduced row echelon form. It's easy for me to do that. And I kind of like it. I really do like it. But I want to point out, we do need to learn something different. What are we going to learn? Coefficient matrix, variable matrix, constant matrix, matrix equation, and then using an inverse to solve that. And we'll talk about that. We'll go through it. It's going to be nasty, though. What do I mean by nasty? Look at these numbers over here. They're nasty for a lot of students to look at. And finding those numbers is equally nasty. Here's the deal, though. Machines can do this incredibly quickly. Humans have a tough time with it, though. But we'll go through it. I'll go through it. And then, certainly inverse of square matrix. It would be nice if you could read through that. However, I want to point out to you, for a lot of students, the words here just get in the way of moving forward. What are we moving forward to? We're moving forward to a basic understanding of what we just asked you, which is basically, we want to get to these examples and we'll work through this. But first, the lecture. All right. So I'm going to go back to the whiteboard. Give me a second, give you another share. And I'm going to talk through it. And as I talk through this stuff over here, my goal for you is to understand the past and then to move forward. So I want to claim, if I were back in Math 100 and someone asked me to do this problem over here, I would say, gee whiz, that looks pretty easy for me to do. I would write this down, 2x minus 3y is equal to 7. And then I'd write down x plus 4y. Yeah, I'd recopy the problem, minus 2. And then I would decide to eliminate something. I'd probably eliminate the x's by multiplying the bottom equation by minus 2. Let me go forward on that. And again, this should be somewhat familiar to you. You've done this for quite some time now. And this is really a very simple technique that you learn in Math 100. Minus 2x minus 8y, and that would be 4. And it's called elimination or addition in Math 100. And what do you get over there? Minus 11y equals 11. And that looks pretty simple. Y is minus 1. And then what would you do? Most people would just go back here and substitute it. That's called substitution to find out what x is. And what would you get over there? Well, let me write this down. X minus 4, because I believe y is minus 1. That would be minus 2. And how would I do that? Add 4 to both sides, I get 2. So I found a point of intersection, 2 comma minus 1. Now, by the way, I'm rather retentive. I want to check it. where would I check it in the original system? I'm going to go back over here, and I want to check in the original system, see if it works. And I'll put this over here. I believe X is 2. This would be 4, 2. And I believe Y is -1. That'd be +3, -4. 4 plus 3 is 7. 2 minus 4 is -2. And I'm seeing that. All right. So that's what you did in Math 100. All right. Then what'd you do? You went to Math 119, of course. And we did this business over here. And what we suggest you do is take this thing over here and write it down as a matrix problem. And what kind of matrix? An augmented matrix. Let me write that down for you. So we write down 2, 1, -3, 4. I put a solid line over there, but occasionally people put, a dash line down, and then 7, -2. And my goal here is to put it down in what's called reduced row echelon form. And the way we did that is, we try to obtain a 0. And I got to be honest with you, it's probably the same exact thing that we did just for the Math 100. So what am I going to do? I'm going to do -2 row 2 plus row 1, and I'll give it to row 2. I'll write that down for you. 2 -3, 7 -2, -8, and 4. Add them together, 0, -11, and then you get 11 over here. And I'll put that down for you. 2 -3, 7. And we get for that second row, it's going to be 0, -11, and 11. Now, someone can say, what are you going to do now? Well, this is where I might disagree with other teachers. Other teachers say, oh, let's do some more row operations. I'm done with my row operations. The reason for that is I can read the second row. And what's the second row? -11y is equal to 11. So I know y is equal to -1. So I can write that down, and I would get 0, 1, -1. Now, so this is, how would you read that? Y equals -1. And then what I would do is no more row operations. I'd go back to my first row, though, and put down what it says. It says 2x. Well, if y is -1, that would be +3 is equal to 7. I solve a very simple problem. This is 2x equals 4, and x would equal 2. And what do you go over there? 1, 0. What does this mean? X equals. What does x equal? 2. This is reduced row echelon form, which we discussed many times before. What does it say? X is 2 and y is -1. Exactly what we expected to see, by the way. All right, exactly what we expected to see. All right. So this is going through those steps over there. We've done this many times before. Now, whether you go back to do what you did in Math 100, or you're doing what you did prior in Math 119, I don't mind. Either way is good by me. What's my favorite technique? Well, I'll be honest with you, both are good. I mean, what you did in Math 100 with writing the system down with the letters in it, or what you did in 119 with the augmented matrix, they're both good. They're both equally easy. All right. Here's something new, though. Now, what's the problem with new things? People don't like new things. They want to go back to the old ways of doing things. And that's a problem. We always want to go back to the old way, including what you did in Math 100. I want to do something new. So what I want to do is look at the original system. I'll take this over here. And I got to talk through it. Give me 1 second here. Let me pull this over here. All right. And push it up a little bit. Take this over here. Let me upload this up a little bit. Okay. Let's talk through it. What they've done. It looks crazy what they've done, actually. But what they've done is they've taken a new matrix and they called it A. And what did they write down? They wrote a 2x2 matrix down with numbers in it. And how do these numbers relate to the system? Well, let's write that down. I see the 2. I see the -3. This is a 1 here. I don't see it, but I know a 1 is there. And I see a +4 here. So what is this thing over here? This is called a coefficient matrix. Coefficient of what? Of the variables in the problem. So if I were to read that, I would say, oh, the first row has 2x's -3 y's in it. Well, I see that. The second row would have 1x and 4 y's in it. And I definitely see that. Then what's the next thing they have? They have this variable matrix. And what's the variable matrix going to be? Well, they write it as a column, x and y. Now, why do I say that? I'm seeing x and y in the problem. I'm seeing those variables. You should notice, though, that we're using an uppercase letter X to represent a matrix, but lowercase x to represent the scalar number for X, all right? A lowercase letter Y for the scalar value of Y. I just don't know what it is yet. Well, in fact, I do. How do I know that? I know what X is up here. I know what Y is over here. I know that already. But listen, this is something new. I didn't do that past yet. We're doing something new now. Let's go to the next page. And then when I get to the next page, I want to talk about, they have something down for this over here too. So I'm going to say we covered the X matrix, we covered the A matrix. And if I put that down, I'd probably go, they're going to have another letter, of course. Let's take a look at it. And that matrix should be 7 minus 2, by the way. Let's take a look at it. And they put this over here. And this is called the constant matrix B. All right. So I want to claim what that original system looked like to me. I'll write this down for you. It was 2x minus 3y is equal to 7. And the other line was x plus 4y, this is from the prior page, by the way, equals minus 2. What they've done, though, is they've written this system using matrices. And that's right over here. So what did they say? It's the matrix A times the matrix X equals the matrix B. And this is written down for you. This is where we're going to introduce the concept of matrix multiplications. It's going to be a little difficult. All right. We're going to go through many examples. The way I like to do this, though, is I like to circle things. I want this to look like my system. I'm going to take this, multiply it by this. I want to tell you what I'm doing. I'm doing row 1 times column 1. And that will give me row 1, column 1 over here. I'm going to write this down. So what do I see? I see 2x minus 3y is equal to 7. I'm going to point out what I just did over here. 2 times x minus 3 times y. That's what I got over there. Equals 7. Let's do the next one. I hate to do circles for you. I'm going to put them circle down for you. Row 2, column 1. Row 2, column 1. Let's write that down. I'm going to do the multiplication. 1 times x is x, plus 4 times y is equal to minus 2. I'm going to put out what I just did. 1 times x, 4 times y equals minus 2. It's right over here. It's the same exact thing. All right, same exact thing. Someone says, this is awful to write that down. It's so much more complicated. Maybe. All right, we got to move forward, though. Let's keep moving forward. All right. So my claim over here is you're going to have an equation, and the equation is going to look like this. A matrix A times a matrix X is going to equal to matrix B. Now, if someone said solve for the variable X, most people would say, oh, just divide by the matrix A. There's a problem. We have no division. We can't do that. I got to erase that. That's crazy. There's no matrix division. Let's erase this. Then the question comes is, how are you going to solve for the variable in the problem? The way we're going to do that is we're going to try to find out what's called an inverse, and it could be very difficult to do. So I'll write this down. Matrix A times matrix X equals a matrix B. Now, you should know that matrix multiplications are not commutative. So what I'm going to do is I'm going to multiply the left side by its inverse. What inverse? A's inverse. It's written this way over here. This gets tough. If you multiply the left side by the A inverse, you absolutely need to multiply the right side by the inverse, but in the same order. What order was that? It was a left multiplication. All right. So my claim over here, what does an inverse do? It undoes the problem. What's the problem over here? It creates an identity matrix. And I'll write this down for you. What's the identity matrix? I'll just write it down as an I now. We'll go to the work later. What's the identity times the matrix X? It's just going to be X. So the problem really boils down to finding the inverse and multiplying it on the B. And that'll give us the variable. All right, let's go through an example. Let's do this one over here. So what example are you doing? We're doing this example up here. So what did they do? I want to point out, they wrote the matrix equation down. This is going to get tough and nasty. There's no doubt about it. So I want to point out the first thing I did was for my system. Right, I'll outline this for you. The very first thing I did was I wrote down the matrix equation, the coefficient, variable, and this is what they equal, the constants. The very next thing I would do is I would multiply both sides of that equation by the inverse of A. Again, this gets tough. All right, so initially what we're going to do, we're going to tell you what this inverse is. We're going to tell you. It looks nasty. All right, it gets tough. I know it gets tough. That's given to you. Don't worry about it. Someone says, where'd it come from? It was given to me. I like when things are given to me. It makes it a lot easier for me. It's going to be tough. What am I going to do now? And I'll talk about it. I'm going to write the inverse down, right? Here comes the nightmare. I've got to multiply. All right, I got to multiply. All right, let me go through this with you. It's going to be tough, though. I'm not going to say it's going to be easier for you. This is a 2 by 2. This is a 2 by 2. Someone says, what are you doing? I'm associating these two together. Well, matrix multiplication is new to me. And what I'm claiming over here is what I'm going to get by doing that is I'm going to get a matrix that is 2 by 2. Let me go through that with you. These dimensions need to match, and I'll tell you why. When I do the multiplications, I need, in the first thing I have 2 columns and 2 rows because they got to match up for my multiplication to exist. And what's the end going to be? A 2 by 2. Right? These are the outer dimensions. All right. Let's go over here. Whoops. Sorry about that. Sorry. I'm back. This is a 2 by 2, and this is a 2 by 1. These need to match. And why is that? It's going to be this times this. So we have 2 columns, 2 rows. What's our outer dimensions going to be? 2 by 1. What does it mean? The result will be a 2 by 1. All right. This is going to get nasty. For a lot of students, they claim they can't do it. I think you can if you try. I'm going to go one step at a time. What I want to do is I just want to do this one first. On the side. And I'm going to go through it with you. It's going to be tough. All right. So 4 11ths, that's what I'm doing. 4 11ths times 7 11ths, I'm sorry, times 7 is 28 11ths. I'll write that down for you. Plus 3 11ths times minus 2 is minus 6 11ths. All right. Let me point out what I did. Row 1 times column 1. Well, that's going to give me row 1, column 1. It's going to give me this entry over here. What do you get over there? 22 11ths, which is 2. Get my eraser out. I know it's tough. Erase this business over here. And I got my result down. What result did we do? Row 1, column 1 is 2. That's row 1, column 1. Let's do the next one. Someone says, what's the next one? And I hate circling things, but I'm going to circle them for you. Row 2, times column 2. That'll give me row 2. I'm sorry, row 2, column 1. This is row 2. This is column 1. It's going to give me row 2, column 1. Let's go through the multiplication. Minus 111 times 7 is minus 7. Whoops, let me go with the black ink. Will give me minus 7 11ths. We'll look at the results later, okay? Now I'm going to do 2 11ths times minus 2. That's minus 4. What does that give me? Minus 11 11ths, which is minus 1. I'll write that down. All right, let me go back over here, and I clearly see it. What do I see? 2 minus 1. Not bad. We did that. So I'm going to say, bingo, bingo. Let's do this over here. It's nasty. I'm not saying it's not nasty. I'm going to pull it aside for you. I want to do this business over here. Pull that up there. I just want to do this business here. I know it's tough. So I'm going to do row 1 times column 1. All right. This is 2 by 2. This is 2 by 2. These need to match up. And my final dimension is going to be 2 by 2. Well, let's go through it one at a time. I want to point out what I'm doing over here. It's going to be tough. This row, this is row 1, column 1. It'll give me this entry over here, row 1, column 1. What do you get? 8 11ths plus 3 11ths. I'll write that down for you. That gives me 11 11ths, which is 1. You can get faster over time, by the way. This is done. That was row 1, column 1. Let's do row 1 times column 2. All right, let me point out what I just did upside down here. Row 1, column 2. Let's do it. 4 11ths times minus 3 and 3 11ths times 4. I'll write that down for you. That gives me a 0 11ths, which I know to be 0. That's done. Cross it out. Now what I'm going to do is I'm going to go to row 2 now. Let's see if I can do it. So I'm going to do row 2 times column 1. And what I'm doing over here. Row 2, column 1. Row 2, column 1. I'm going to get this entry now. Let's see what we get. Minus 2 11ths. I'm doing this times this and this times this. Plus 2 11ths, which is 0 11ths, which is 0. That's done. Let's do the next one. We're going to do row, maybe I'll lose track of that, right? Row 2 times column 2. By the way, this is done. I see if we can do that. 3 11ths, that's minus 1 11 times minus 3, plus 8 11ths. And what does that give me? 11 11ths. What's that? 1. All right, let's see if we did that correct. Who knows? It looks pretty nice and neat there. And let's go back to our problem, see if we got that. And I see it. It's right over here. I want to put out what we're going to do now. We're going to do this on the side. Let's see if I can do it. But before I do that, I want to claim to you that, let me see if I can clean it up a little bit first here. Gee, I don't know if I can clean that. No, I can't. I'm sorry. You get the idea, though. All right. So let's write this down. This is 2 by 2. This is a very special matrix, by the way. And this is a 2 by 1. These need to be matched. And I'll tell you why they need to be matched. It's this times this. So row 1 times column 1. And write that down for you. Row 1 times column 1. And what's that going to give you? Well, if I did that, what would I get? I get x plus 0y, which is x. I'll write that down for you. That's row 1, column 1. That's done. What's next that going to be? Row 2 times column 1. What do you get over there? 0x, whoops, go back to black. 0x plus 1y would equal y. All right, let's go back. And we got it. Exactly what they said it was. Now remember, we did this, and we did this one before. They're both 2 by 1. What does it say? Well, they're equal matrices. It says x is equal to 2, and y is equal to -1. All right, let me briefly talk about the identity matrix. All right, I'll write this down for you. It's going to be a square matrix. So if I said I2, what's I2 going to look like? 1, 0, 0, 1. If I write down I3, what would that look like? 1, 0, 0, 0, 1, 0, 0, 0, 1. If I wrote down I4, which we're not going to really get to, what's that going to look like? It's a 4 by 4. 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. What do we notice about these guys over here? The diagonals are 1 and everything else is a 0. So the diagonals are 1 and everything else is a 0. And they're square. What's nice about identity matrix? They don't change the thing you're multiplying it by. So if you took I and multiplied it by a matrix A, dimensions got to be compatible, by the way. It's not going to change it. All right, that's what we like. All right, we'll still go through other examples. I want to plan that this example is done over here. What's the problem with this method, though? And I want to tell you what the big problem with this is. Finding the A. I'm sorry, the inverse of A. That's trouble. We'll go through the technique for it. Go next page. And I want to talk about this problem over here. And we'll talk about it in stages. All right. Now, this is a linear system. There's 3 equations, 3 unknowns. There's 3 equations, 3 unknowns. All right, I'm seeing the x unknown here, the y unknown here, the z over here, and the constants over here. I like this technique over here. What is this going to be? What we've done in the past. We wrote down an augmented matrix. I don't want to repeat that with you, but you know what? You can't have to repeat it yourself. And I would do some elementary row operations. And eventually I'd get to this, what's called reduced row echelon form. Generally speaking, if the problem's written where it's not horribly difficult, it's really easy to get to this reduced row echelon form by using what's known as elementary row operations. And it's really, generally speaking, it's not bad to do, provided the numbers are not outrageous. But machines can do it pretty quickly. And how would I read this problem over here in the end? I would say, oh, gee, it's in reduced row echelon form. I know this is x equals 1, y is equal to -2, and z is equal to 3. But we need to move on to something different. And what we're going to move on to is we're going to be writing down the matrices now. And again, I'm not going to say it's going to be easy for you. It's nightmarish for some students, not everyone. So I'm going to say, you know, what's A? It's still the coefficient matrix. Whoops, sorry about that. And what are the coefficients? Well, the x coefficients are 2, 3, 2. I'm looking at the system over here. 3, -3, 4, -1, 1, and 1. Okay, variable matrix. So over here. What's that going to be? Well, what are the variables problem? X, Y, and Z. I'm seeing that. What are the constants? I'm going to look at it. -7, 12, and -3. Now, what they said? Well, if you knew those 3 matrices, that is the matrix A, the matrix X, and the matrix B, you could write a matrix equation down. All right, let me go through this again with you. A, X, equals B. You notice when I write it on the blackboard and I'm not typing it, I got to put that little arrow above it indicating it's a matrix for me. It's a way of making. What's the size of A? 3 by 3. That's A. What's the size of X? Well, there's 3 rows and 1 column. What's the size of B? There's 3 rows and 1 column. These need to match, and this will give me the outcome, which is 3 by 1. All right? All right. Here's the problem. I have to solve that equation. And I want to just simply write it down for you. So if I were solving that, I need to solve for the variables. Remember, we have no division for matrices. What do? I multiply both sides by the inverse of A. And we'll go through that in a moment. All right, here's the problem. When you do this, you need to find A inverse. But if you were to do that, what you'd find is I. Now for this system, I is going to be I3. What's I times X? It's just X. So this problem really boils down to, do you know A's inverse and are you willing to multiply it onto the B? And I say yes. So if I see this, I can immediately write down this, that the answer to the problem is going to be A inverse times B. I can immediately write the answer down. What's the problem? Finding the inverse. Okay, I'm going to go to the next page. And I want to point out what I just talked about before. And as I write this down, it's going to be a little slow. I know that. We're taking this row times this column. And I'm going to write down what I want you to do. Okay, so let's talk about this. Row 1 times column 1. I'm going to write that down for you. And what do you get? 2x plus 3y. We want to put out what we're doing. We're doing 2 times x, 3 times y, and then minus 1 times z. What does that give you? Write that down for you. Plus minus 1 times z. I'm just going to put down minus z. And that's supposed to equal row 1, column 1 of this guy over here. And what's that going to be? Minus 7. That's done. Now let's do row 1. I'm sorry, not right. I'm sorry, row 2 times column 1. What do you get over there? 3x minus 3y plus z equals row 2, column 1 of the outcome, which is 12. All right, let's do next one. Row 3 times column 1 is going to give me what? 2x plus 4y plus z is equal to minus 3. All right, I'm going to copy this. This is what you want to do when you study. You want to go back to the prior page. And whoops, sorry about that. And I'm going to paste it right over here. Let's take a look. Is it the same thing I expected it to be? And if it's not, maybe we made a mistake somewhere. 2x plus 3y minus z equals minus 7. I see that there. 3x minus 3y plus z equals 12. 2x plus 4y plus z equals minus 3. Wow, same system. That's going to take practice on your end. Here comes the tough part. Solving the equation. All right, remember, and I want to circle this for you so you know what we're talking about over here. On the prior page, we called this thing A. On the prior page, we called this thing X. On the prior page, we called this thing B. And then what we do, we write a matrix equation down. Let me outline that for you. And I claimed that we could write an answer down immediately if we knew the inverse. Well, here's the problem. We have to compute the inverse. Machines can do this incredibly quickly, though. But I want to write down what the inverse of A is, right? So A inverse, it's written like this too. And yes, a computer can write it that way as well, is equal to this thing over here. Now, I realize someone's going to say, that's a nightmare. I can't do that. I think you can. We're not there yet, though. A machine can do it, and we'll talk about that. But what do I want to do? I want to take A inverse and multiply it by this. Okay? Let's see if we can do that. And it's tough. I'm not saying it's going to be easy for you. Right? Do I know what A inverse is, though? Yeah, it's over here. It's kind of a nightmare, but I can write it down. And I'll go through the work. I want to say work, not inverses yet. I'll go through the work of doing a multiplication. Blow this up a little tiny bit. And I'm going to write this below it. This is a 3 by 3, and this is a 3 by 1. These are matching. And my result is going to be really simple. It's going to be a 3 by 1. My claim, it should be incredibly easy to do, provided you can do arithmetic. I'm going to write this down. Row 1 times column 1. What would that give me? Minus 7 this. I want to point out what I'm doing. This times this times this, and this times this. Let's keep going. So minus 7 fifths plus 12 fifths plus 0. And what does that give me? 5 fifths, which I know to be 1. That's row 1, column 1. Let's do the next one. I'll write this down for you. Row 2 times column 1. Minus 7 35ths. Put out what I'm doing over here. This times this times this, and this times this. Yep, you need to not do arithmetic. Minus 48 35ths. And then what do you get over there? Minus 3/7. More difficult, isn't it? Let's put this down. Let's see, minus 7 minus 48 is minus 55. And then I'm going to write the other guy in terms of 35ths, and that's going to be minus 15 35ths. Minus 55 minus 15, minus 60 minus 70 35ths. And that turns out to be minus 2. What's that? Row 2, column 1. And that's going to be what? Minus 2. All right, let's go to the next one. I know it's tough. We're going to try to encourage you to try them. I'll do this one now. So we're going to do row 3 times column 1. Oh, this is going to be tough. And I'll write it down for you. I have to do minus 18 35ths times minus 7. Well, you know what? I had grade school arithmetic. I know it's a positive number. And 7 goes into 35 5 times. So it's 18 fifths. Let's do the next one. That's going to be, let's see, 12. I'll write this on the side for you. Times 2 35ths. Right? And what's that going to give you? 24 35ths. It's tough. I'm not saying it's going to be easy for you. Last but not least, you get 9/7. I bet this is going to work out pretty nicely, though. Let's see. I say common down to 35. Let's see. 7 times 5 is 35. So 7 times 18, that's 70 and 56. Well, 24 35ths, 24. And 5 times 7 is 35. So that's going to be minus 45 now. Whoa, that's a lot of arithmetic, isn't it? See what we get. 35. I kind of add this together. 56 and 24. That's 60, 70, 80. Right? That's 150, 105. That's a terrible number, huh? But you know what? 35 goes into 105 three times. That worked out really nice. So why do they work out so nicely? We write them to work nicely. So we get 3. All right, so let's go back and let's see how we did. And I've been looking at it. And what do I see over here? Well, I did it. It's right over here. 1 minus 2 and 3. So I know what x is. X is 1. I know what y is. Y is minus 2. I know what z is. Z is 3. Now, granted, I realize something I'm going to play. It's really a lot of work for me to do, and I don't even know how to get an inverse yet. Well, we'll get there. You want to move forward, though. All right. It's going to be tough. We'll go through it, though. The inverse of a square matrix, right? If there exists an n by n matrix, a inverse such that blah, blah, blah. Remember we said about this n, it's square. So it's a 3, it'd be a 3 by 3, a 2 would be 2 by 2, 4, 4 by 4. All right. Were they saying that if you took the matrix A multiplied by its inverse, whether you did it left or right, it's always going to produce the I matrix. And that I has a diagonal of 1s. All right. Now, granted, you may look at this and say, I don't understand what I'm reading. Well, it's going to happen to you a lot. You're going to read things. You'll have no comprehension of what you're reading. All right. But we're looking for this inverse matrix. We're looking for it. We're looking for that A inverse. And they talk about the diagonal entries being 1 and everything else being 0. All right. I'm going to claim, though, that a lot of students find this very difficult to do, to find that. We'll go through the method, though. We'll cover how to verify that the matrix are inverses. So we're going to cover how to verify. We'll also develop a technique, a simple technique, to find inverses. By the way, that's for matrices that have inverses. Don't believe that all square matrices have inverses. They don't. Some don't. However, I want to strongly suggest that you learn how to find an inverse using a calculator or possibly using Sage. It may prove difficult for many students to do it by hand. However, as we start doing problems, I'll outline a procedure. And by the way, the procedure you already know. It's basically solving a system of linear equations. Now, sometimes if you're going to do that, why don't you just go back to reduced row echelon form? And I'll be honest with you, that's exactly what I would do. I would never go for inverses unless I had a machine to do it. All right. But again, I want to claim that your graphic calculators or your cell phones are able to compute inverses. And the reason for that, they're just really good at matrix algebra. They really are. All right. They're really good at it. Okay. So I'm going to say we haven't done an inverse yet. You would have given to you, but we need to come up with a technique to do that. And we'll do that by example. So we're going to do this by example. Examples to follow. Thank you for paying attention.